Now let's look at something equally interesting. Equal chords in the circle. Look at the diagram on the right. You see two chords, AB and CD. They look about the same length, but how can you tell? So here's a rule to help us prove that. If two chords are the same length, they are the same distance from the center of the circle. In this example, the center of the circle is O. From O, we can draw two lines going from O to the middle of each chord. There will be OH and OG. Both of these lines meet the chord at right angle. So here's the idea. If AB equal to CD, then OH should be equal to OG. That means both chords are the same distance away from the center. The reverse is true as well. If OH equal to OG, then AB equal to CD. In other words, if two chords are the same distance away from the center, they must be the same length. This is one of those facts that help us to compare chords without actually measuring the length. We just look at how far from the center. The key word here, remember, is equidistance. It means equal distance. Be sure to look out for right angle and distance from the center in questions. These are the clues that you should be applying this equal chords concept to the questions. For this question, a circle with center O has radius equal to 5 cm, and the perpendicular distance from the center to the chord CD is OG, which is 4 cm. If AB equal to CD, find the length of BH. Please take some time to think of how to solve this question. Once you are done, resume the video. Now, since we know that AB equal to CD, we know that the perpendiculars from the center, OH and OG, should be equal, meaning OH should be equal to OG equal to 4 cm. OB equal to 5 cm because that's the radius of the circle. And we know that triangle OBH is a right triangle because it has an angle of 90 degrees. Therefore, with Pythagoras theorem, OB squared equal to OH squared plus BH squared. So BH will be equal to square root of OB squared minus OH squared, which will be 5 squared minus 4 squared. So we have square root of 25 minus 16, which gives us square root of 9 and give us 3.